Okay, so welcome guys. Good morning. We are doing this launching vehicles. Okay, so in the launch vehicles, I have told you how many generations? Five generations. So first gen, which is satellite launching vehicle. Okay, and which has four stages, and all the four stages are sorry. Okay, so here with generation, what happens is the weight carrying capacity will increase and the distance will increase. On the other side, the weight will decrease. When I say weight, the weight of launch vehicle. Okay. Next, second generation, augmented satellite launching vehicle. Okay, augmented. Repeat after me. Augmented. Okay, which has five stages. All the five stages are solid, 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 solid. Okay, and then we have moved to third generation. See here range is 50 kgs. Yes, 400 kilometer. Okay, here we have increased the weight to 150 kgs. I mean similar. Okay, so we have written lower earth orbit. Okay, see here just by increasing one extra stage, we have increased the weight carrying capacity. That's all. Now, third generation polar satellite launch vehicle. Okay, now it has four stages. Okay, solid, liquid, solid, liquid. Okay, and then we have entered into fourth generation GSLV, geostationary satellite launching vehicle. Here we have three stages: liquid, solid, and then cryogenic. Okay. And then see when I say GSLV fourth generation, here we'll be having this LVM 1 and LVM 2 or GSLV Mark 1, Mark 2. Okay. And then we started with fifth generation. Now fifth generation is GSLV Mark 3 or LVM 3. This also has how many stages? Three stages: solid and cryogenic. Okay, so this also has three stages. Okay, fine. Now, see, we'll see the difference between this PSLV and GSLV. Okay, so write down the difference. PSLV, Polar Satellite Launching Vehicle, and Geostationary Launch Vehicle. Polar Satellite Launch Vehicle, Geostationary Launch Vehicle. Okay. Okay. So using this vehicles, we launch polar satellites generally. Okay. Using this vehicle, we launch polar satellites. Okay. In which orbit? Polar orbit. Polar orbit. Okay. Using this launch vehicle, we launch INSAT or GSAT in geostationary Earth orbit or GTO, geosynchronous transfer orbit. Okay, first difference. Done. So basically, PSLV is for polar satellites, and these polar satellites generally will launch in polar orbit. And GSLV is generally designed for INSAT or GSAT that will be launching in geo or geosynchronous transfer orbit. Okay, but there are some exceptions. Right on. IRNSS. What is this IRNSS? Hmm. Indian Regional Navigation Satellite System. Okay, so which is a constellation of 7 satellites I have told you. Okay, 4 are in geo and 3 are in GTO. Okay, and one we replaced recently with NVS2. Okay, when we launched this IRNSS, which means these 7 satellites, okay, we have used polar, I mean, this PSL. We have used PSL. So generally PSLV is used for polar orbit. Here we have used PSLV to launch in, yes. Here we have launched 4 and here we have launched 3 using PSLV. So this is first exception. Okay. Why, I'll tell you the reasons. Right down. IRNSS. Quite important. Okay. Next one. Next exception. PSLV C11 on 22nd October 2008, which is Chandrayaan 1. Chandrayaan 1. Chandrayaan 1. Chandrayaan 1. Chandrayaan 1. Okay. And using PSLV C25, we have launched Mangalyaan 1. Mom. Mangalyaan 1. Mom. Mangalyaan 1. Mom. Okay. Fine. This will call it as Mom. Moon orbiter mission. Sorry. Mars orbiter mission. Okay. So see, on one side, what am I telling you is polar satellite. It is generally for polar orbit. Okay. But we have seen we have launched in GEO and GTO, which means by using polar satellite we have reached 3,000, 36,000 kilometers. Yes. Later, using PSLV, we crossed 36,000 kilometers and we have reached moon. We have crossed further, and with C25 we have reached till Mars, Mangalyaan. So these are 3 exceptions. Okay, how can we do this? I'll tell you now. Okay, on that side write down variants. 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 First variant is GSLV Mark 1, and this is again of two types, I9 and I6 variant. I9 and I6 variant. This can carry a weight of 1500 kg and it can install in GTO or above GTO. And this can carry, what happened? Okay. This can carry a weight of 1900 kg and it can install in GTO or above GTO. GTO means geosynchronous transfer orbit. This is the data which is given in ISRO website, okay? Okay, next. GSLV Mark 2. GSLV Mark 2. Okay. Again, see, it can carry a weight of 2500. It can install in GTO or above GTO, and it can carry a weight of up to 5000 kgs and it can install in LEO. Which means if you are carrying more weight, okay, you can reach only till LEO, lower Earth orbit. If you are carrying more less weight, then you can reach till 36,000 kilometers and above. Okay, if more weight, more fuel will be consumed, so less distance will be traveled. If less weight, less fuel will be consumed, so more distance you can travel. No worries, everything you'll understand now. Okay, so first write down these things. Done? Yes. Now we are left with one more variant, which is GSLV Mark 3. GSLV Mark 3. Okay. So using this, we can carry 4000 kgs weight and we can reach GTO or above GTO. And we can carry 8 to 10 tons. Okay. Which means 8,000 to 10,000 tons. And we can travel till LEO. Okay, so again same formula here. Less weight, less fuel, less distance. More distance. Okay, more weight, more fuel, less distance. Okay, now here keep a note point. Keep a note point. 1425 kilometers, 1425 kilograms GTO or above GTO, and 1750 kilograms lower Earth orbit. Lower Earth orbit. Lower Earth orbit. Okay. Okay. Now a current affairs point. Now tell me, we have launched the NVS 2. Yes. Okay. And the Mass of NVS2 is, see, 2250 kgs. 2250 kgs. Okay. Now tell me which vehicle we'll be using. On one side we have PSLV. See, before we have launched the IRNSS with PSLV. But now slowly we are replacing each and every satellite with advanced satellites like NVS-02. Now, what I have told you, the NVS-02 satellite weight is 2250 kgs. So, can we launch 2250 kgs with Polar satellite launching vehicle? No. So, Polar satellite launching vehicle maximum we can carry 425 because we have to launch this NVS2 in GTO. Yes, NVS2 what it will do? It is a regional satellite. Okay, so it will concentrate only India from 36,000 kilometers. So it will help India for navigation system. Okay, so it has to install in GTO. Okay, so now which vehicle will be used? Obviously, GSLV will be used. Okay, so see 2250. So obviously here this will be used. This will be used. So that's the reason the vehicle which we have used here is GSLV F50. Okay. Next, see IRNSS. IRNSS. This is 1100 kgs. All the satellites together. How much it is? 1100 kgs. So now tell me which vehicle we'll be using? 1100 kgs PSLV, and we have to install this in GTO. So till GTO and above GTO we can carry a weight of 1425. We have to simply weight uplift 1100. So here we have used PSLV. So understood this one? Here we have used PSLV. But generally to launch a vehicle, I mean a satellite in GEO or GTO, what we have to use? This one. But here the weight is quite less, 1100 kgs. 1100 kgs. So what we have used? PSLV. Okay. Now see. Chandrayaan 1. Chandrayaan 1. 1380 kgs. How much? 1380 kgs. Okay. Now tell me 1318 kgs. So which vehicle will be using? PSLV. Because GTV or above, we can carry up to 1425. Okay. The weight is 1380. So we can simply use PSLV instead of using GSLV. Again, this Mars mission, Mission Mangal. Okay. So here the weight is 1350. So obviously we'll be using PSLV. Understood? So because of the weight, we have used these things. Okay. Because this is 1380 kgs, we have used PSLV. And because this is 1350 kgs, we have used. See, what happens is, if you have seen this Mission Mangal movie, Mangalyaan, okay, there first they'll ask for this GSLV. Then immediately ISRO will say them like, MNC, we don't have budget this year. Okay, and next year, anyways, they are not going to plan because on that particular year, the Mars is very close to Earth. If they have to reach Mars, okay, on that year only they have to try, or else they have to try again in 2027 or 2026. That's the reason they are eagerly asking for the budget. But the thing here is they won't provide the budget. So what they'll do is, instead of using GSLV, they'll try with PSLV. But if they have to use PSLV, then immediately they have to decrease the weight below 1425. So they'll try initially, they'll show you around 3000. Okay. Slowly they'll come up with synthetic fibers and all, and they'll decrease the weight. Have you seen this Mission Mangal? If not the case, please see today. Okay, wonderful movie. Yes, please. I mean, because I mean, this is really helpful for you now. Fine. So Mission Mangal, you have to see now. Okay. Fine. So what they'll do is they'll slowly use the technology. Okay, and slowly they'll reduce the weight. Their complete concentration is in reducing the weight only. That's how they'll achieve a weight of 1350 kgs, and finally they'll launch the things using this PSLV. Okay. In the PSLV also they'll use a technique that we'll discuss later in Mission Mangal. Okay, mom. Okay. So these are the examples for PSLV. Understood these one? Okay. Generally we'll use polar satellite to launch in polar orbit only, but here we have used for different purposes because on the weight basis, mass basis. Yes. Now see examples for this. Chandrayaan 2. Chandrayaan 2. Chandrayaan 2. Here the Chandrayaan 2 weight is 3,877 kgs. 3,877 kgs. Okay. So now tell me 3,780, 877 kgs. So obviously which vehicle will be using? GSLV, that too Mark 3 variant. Okay. So GSLV Mark 3. And yesterday I have shown you M1. To differentiate, just to differentiate, we have given names to the vehicles. And the name for this is M1. And Chandrayaan 3 is M3. Yes. So my point here is, here we have used GSLV Mark 3 because the weight is 3,877 and we have to reach GTO and above. Okay, that's the reason we have used GSLV Mark 3. Okay, see now your current affairs will be easy for you. See, whenever current affairs, something is going on in the current affairs, just like this NVS2, first what you have to do is, first what is this NVS2? What kind of satellite it is? We have three kinds of satellites. Okay, one is remote sensing, second one is Earth Observatory Satellite, and third one is INSAT or GSAT. Okay, I mean, leave this INSAT, what? GSAT. Okay, so first you need to see what kind of satellite it is. Okay, so we are so far clear, this is a GSAT. Okay, next what you have to see is, like, what is the mass? What is the mass? Based on the mass, you'll get to know, I mean, even you will decide which vehicle they are using, then compare your assumption with the actual thing. Okay, and obviously you'll get to know, like, they are using PSLV or GSLV. If they are using GSLV, then what is the vehicle name? GSLV F15. Okay, if that is of this variant, then obviously they'll write it as GSLV Mark 3 M1 M2 M3 M4 M5. Okay, understood? So whenever satellites are launching, first you have to see what kind of satellite it is, and then what is the load, weight, and then which vehicle they are using, and finally what's the purpose. This is your current affairs. Now NVS2, this is part of IRNSS, 7 satellites constellation, in which one we are replacing. Okay, so weight is around 2,300 kgs. Okay, and which vehicle we are using? GSLV. So the name of the vehicle is GSLV F15. Done. Simple. Yes. Okay, next one is Chandrayaan 3 example. Chandrayaan Chandrayaan 3. Okay, here the weight is 3,900 kgs. 3,900 kgs. So obviously the vehicle which we'll be using is GSLV Mark 3. Okay, so here also GSLV Mark 3, and this time M3 variant. Okay, name is given as M3. Okay, later we'll see the details. Okay, each and every mission will do individually, then I'll give you more details. Okay, done. Okay, and write down 2 more examples. Gaganyaan. Gaganyaan is the kind of mission wherein we'll send our astronauts to the space. Okay, Here, obviously, the weight will be more because life supporting system will be there in the Gaganyaan and astronauts will be there. So everything is full packed. So obviously, the mass will be more. Okay, the mass will be more. But see, here the point here is they have to reach to lower Earth orbit. See, we cannot send our astronauts to 3,000, 36,000 or above 36,000. Okay. So initially, first we'll send our astronauts to lower Earth orbit. Okay. So this Gaganyaan mission is 7,000 kgs. Here, our mission is to send astronauts to lower Earth orbit. Okay. Now tell me 7,000. Okay. 7,000 and we need to send them to lower Earth orbit. Lower Earth orbit. So here also, instead of using that, we'll use this. Okay. GSLV Mark 3. Last one. One more example. Right now. Okay. Space Station of India. Space Station of India. Space Station of India. So we are trying to construct a space station. Okay. So space station also will be there in lower Earth orbit only. Where? Lower Earth orbit only. Okay. So lower Earth orbit, here the weight is 20 tons. Here the weight is 20 tons. Here the weight is 20 tons. Okay. So obviously which vehicle will be using? GSLV Mark 3. But the thing here is the maximum capacity of GSLV Mark 3 is 10 tons. 10 tons. So what we'll be using is, see, this is 10 tons. So what we'll be doing is, now recently we have seen a machine which is in news, which is SpaceX. Have you seen this? Okay. So here what happens is, here this is a technology of docking technology. Docking technology. Now we'll use this docking technology in the space station. Let's say a space station have 10 rooms. How many rooms? 10 rooms. Now total 10 rooms is weighting 20 tons. Now single room will weight 2 tons. Okay, so 2 tons. Now what we'll be doing is, first we'll send a room. Okay, and then we'll send one more room. Okay, now we'll try to combine, attach both the rooms in the space, and this attachment in the space is called as docking technology. This attachment in the space is called as docking technology. Okay, so this is all about, see, recently we have sent a thing into the space and we tried docking technology, and so far we have succeeded. See, in the docking technology we have we'll be having a chaser and we'll be having a target. We'll be having a target. Okay, let's say I have told you the space station has 10 rooms. Example, let's say we have already sent one room. Now second time we are sending another room. Okay, now this first room will be target and the second room will be chaser. Now this chaser will go to target and both will be attached in the space, and this technology is called as docking technology. Okay, third time when we'll send the third room, what happens is already two rooms are there. Now these two rooms are becomes target and this will become chaser. They'll go and they'll attach to this two rooms. Okay, and this is called as docking technology. So in this SpaceX, what happened is we have tried chaser and target, which means we have sent two things. Okay, and we tried docking technology in the space. Okay, and the weight of both the things are, first one is, both are 220 kgs. How much? 220 kgs. So obviously, generally we'll use space station. For space station, we'll use GSLV Mark 3. GSLV Mark 3. But here, the weight is just 220 kgs. So obviously, which vehicle we have used? 440. So 440, that too in the lower Earth orbit. 440, that too in the lower Earth orbit. So obviously, PSLV we have used. So now you can see in your current affairs, you can check about the SPADX. Okay, in the SPADX we have used PSLV vehicle because the weight is 440 kgs. Okay, so conclusion is, if I'm telling you PSLV, JSLV, it doesn't mean PSLV is used only for polar orbit. Based on the weight, we can use it anywhere. We can use it anywhere. Okay, and thus we are not using only in the geo and above geo. Okay, this also we are using in polar orbit, just like to launch Gaganyaan and just like to launch this space station. Okay, so GSLV, PSLV will be using in both polar and geostationary orbits. But the thing here is, it is purely dependent on the mass. It is purely dependent on the mass. Okay, then you have written all the things. Last, SPADX. Okay, I mean, this is your current affairs, nothing else. So today, what you will be doing is, I mean, after going home, okay, write down this SPADX, okay, search from your end, and then NVS02. Okay, if you have any doubts, post it in the group, I'll explain. No, nothing is there to understand. Everything I have told you. Okay, now tell me, all these launch vehicles we are making in which station of this ISRO? Hmm? Thiruvananthapuram. Thiruvananthapuram. These vehicles are launching from Sriharikota. Okay, Satish Dhawan Space Center. But these vehicles we are making in VSSC, Vikram Sarabhai Space Station, which is in Thiruvananthapuram. Okay, so these vehicles we are launching from Satish Dhawan Space Center, Sriharikota, Andhra Pradesh. Okay, now done. Okay, okay. Now see, I'll give you. See, I keep on talking about solid kind of fuel, liquid kind of fuel, and I have told you there will be oxidizer. Oxidizer. Okay, so now let's write down the names. Okay, but these names are not important at all. Just to tell you, I'm telling you, but nowhere these are important. Okay, so oxidizer generally will use N2O2, N2O4, or nitrogen oxide. Okay, so nitrogen oxide, nitrogen oxide. And the solid type of fuel we'll be using is hydroxyl terminated polybutane. Hydroxyl terminated polybutadiene. Hydroxyl terminated polybutadiene. Okay. And the liquid kind of fuel is unsymmetrical dimethyl hydrogen. Unsymmetrical dimethyl hydrogen. Unsymmetrical dimethyl hydrogen. unsymmetrical dimethyl hydrogen. Okay, so these are the fuels we'll be using in the launching vehicles. Okay, so when I say solid, we will not be using coal over there. When I say liquid, we will not be using petrol or diesel over there. Instead, the names are this. Okay, oxidizer is nitrogen oxide. Okay, and obviously this will be in which form? Liquid, solid, gaseous. Which form? Liquid form. A liquid form. Gaseous we cannot use because I have already told you there will be friction. So that's the reason in the launching vehicles there is no formula of using gaseous. Okay. Now keep a heading as GSLV. 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 Right now. Third stage of GSLV is totally different. Third stage of GSLV is totally different. Third stage of GSLV is totally different, and that is cryogenic. And that is cryogenic. And that is cryogenic. And that is cryogenic. Okay. So in the cryogenic, what will be happening is in the cryogenic, what will be happening is we'll use liquid hydrogen fuel, liquid hydrogen as fuel. Similarly, liquid oxygen as oxidizer. This we have already discussed before. Okay. So generally hydrogen fuel is in gaseous form. So what we'll be doing is like we'll compress the gas and we'll give the temperature at minus 253 degrees Celsius. There the hydrogen gas will be converting into liquid, and this will fill in the rocket, and we'll call this as cryogenic engine. Okay. Similarly, oxygen also generally it is in gaseous form. So we'll compress and we'll give a temperature of 183 degrees Celsius, and we'll convert it into liquid form, and then we'll fill this in the launching vehicles, and we'll call this again as cryogenic engine. Cryogenic engine. Okay. Now write down two facts. Facts. First GSLV. First GSLV. First GSLV. First GSLV is GSLV D1. GSLV D1. GSLV D1. This we have used to launch a satellite called GSAT 1. GSAT 1. Okay. And here obviously GSLV means cryogenic engine will be used. But in this was happened in 2001, and in 2001 we don't have the technology of cryogenic engine. So we borrowed Russian technology. Russian technology for cryogenic engine. We borrowed Russian technology for cryogenic engine. That's the reason Russia is still our good friend. Every time Russia is only helping us out. Okay. So then, when we have got the technology in 2014, we have got the technology, and which station has done this technology? LPSC, Mahendragiri, Tamil Nadu. LPSC, Liquid Propellant Space Center. Liquid Propellant Space Center, Mahendragiri, Tamil Nadu. So station simple. See, already three we have anyways revised. One is Andhra Pradesh, Satish Dhawan Space Center. Okay, to launch the vehicles. And this liquid propellant, so obviously LPSC, Liquid Propellant Space Center, Mahendragiri, Tamil Nadu. And launching vehicles will be made in Thiruvananthapuram, Vikram Sarabhai Space Station. Okay. So, I mean, see, with the things you need to link the facts. Okay. Then it is easy to remember the facts. Okay. So, finally, in 2014, we have got the technology, and in 2014, we have launched GSLV D5. GSLV D5. And using this GSLV D5, we have launched GSAT 14 in 2014, and this is indigenous technology. Indigenous technology. This is indigenous technology. So LPSC made the cryogenic engine here. Indigenous technology. Okay, so these are some facts associated with this GSLV. So in the GSLV, I have told you we'll use cryogenic engine. Cryogenic engine means fuel cell. Okay, you remember fuel cell concept? Hydrogen. Okay, so same here. What we'll be doing is like hydrogen will be using as a fuel, and there in the space we don't have oxygen. So oxygen also we are compressing and we are giving it a liquid form, and we are using that in the cryogen engine. In the cryogen engine, you will find liquids, the combination of both hydrogen fuel and oxygen. So obviously fuel will be less in percentage, oxidizer will be more in percentage. Yesterday I have told you, right, 15% is fuel and remaining 85% is oxidizer. Okay, so same ratio. Fine. Okay, next write down jet engine technology. Jet engine technology. Jet engine technology. Jet engine technology. This I'll complete and then I'll give you break. Later we'll start with missions, successful missions of India. Okay, Chandrayaan 1, okay, Mangalyaan, okay, Astrosat. All these missions will start, but first we'll complete this and we'll take a short break. Okay, fine. See, when I say jet, generally people will compare it with commercial planes. Yes, commercial planes. So let us have a comparison between commercial plane and jet. Okay, commercial plane and jet plane. Okay, write down the differences. Commercial plane and jet plane. Commercial plane means the plane which you are taking. Okay, in the geography, have you done with this troposphere, stratosphere, ionosphere? No. Okay, fine. See, okay, fine. So troposphere is close to Earth, okay, and stratosphere is next layer for now. Okay, remaining things you'll get to know in geography. So generally, these commercial planes they will be in troposphere. Okay, generally, okay, mostly, almost these planes will travel in troposphere only. Not about that. But in your NCRTs, they have given stratosphere also, so I'm including stratosphere also. But generally, okay, see the flights they'll take a height of up to 3,000 feet, 4,000 feet. Okay, not more than that. So 3,000, 4,000 feet means merely 10 kilometers. So if it is coming under 10 kilometers, obviously they are traveling only in troposphere. Okay, so mostly flights will take in troposphere only. Okay, they won't reach the stratosphere, but NCRT they have given this stratosphere. That's the reason I am writing here it as stratosphere. Okay, otherwise it will generally they are in troposphere only. Okay, but this jet planes they will be in stratosphere. They will be in stratosphere. Right on. They will be in stratosphere. Okay. So from here, UPSC has asked two questions. Okay. First one is based on turbulence. Okay. And second one is oxidizer. Second one is oxidizer. Okay. Now we'll solve both the questions and then we'll leave the topic. Okay. See, generally when it is close to the earth, commercial planes, when it is close to the earth, which means when they are in troposphere, they'll face both the horizontal winds and the vertical winds. Yes, in the geography you will see whenever low pressure kind of situation happens, the winds will flow in this direction and then they'll take horizontal direction and they'll reach some other place, so winds direction will be there. Okay, so in the troposphere we'll see both horizontal and vertical wind flow. Okay, see, generally see what happens here is, see, let's say I have heated a pan. Okay, now this pan is in high temperature. Okay, this pan is in high temperature. Now the air which is coming in contact with the pan will be heated up. Now after getting the heat they will move to upper surface and remaining cold air is there na. Okay, this cold air will be dense and it will come down. Okay, so this will happen in troposphere. Even I mean, what is happening with your water whenever you are boiling the water? See, generally you will give the flame. Okay, initially cold water will be there, so this cold water will gain the heat. Once after gaining the heat it will become hot water. Hot water is less dense and they will go upside. Okay, and there will be a convection and we will call this as conventional forces. Okay, so this convection, what happens is this hot water will reach in direction and cold water they'll come in this direction. Slowly entire water will get the same temperature. So in the atmosphere also same kind of situation will be happening. What happens is once the air is getting the temperature, the winds are getting the temperature, they'll take upward direction. Okay, this upward direction is nothing but your vertical wind. Okay, in the cooler areas what happens is generally the air which is above is hot and the air which is in contact with the earth is cool. Okay, so here what happens is they'll come down. Okay, cool air will come down. Okay, so here in the cool areas what happens is this will go up, reverse will happens. Okay, so slowly what happens is generally, okay, the air in the hot areas they will move in up direction. Okay, and they'll reach to a cooler area and they'll go in down direction. Again they'll travel here and they'll go upward direction. This will be there in the atmosphere. Okay, this in geography they'll explain you in a better way, but this is the scenario. Okay, just like water in a bowl. Okay, now let's say this is troposphere. Okay, in the troposphere we'll have both horizontal and vertical wind directions. Horizontal and vertical wind directions, but in stratosphere only horizontal wind direction will be there. Okay, so vertical wind direction will not be there in stratosphere. Okay, so if you didn't understand the concept, leave it aside. Okay, only two facts. One, in troposphere you have only, you have both vertical and horizontal winds. Okay, so generally we'll feel both the winds. Okay, after going to a height only horizontal winds will be there. Okay, this is the concept. See, when vertical and horizontal directions are there, okay, now let's say this is your flight, then obviously this will be disturbed by vertical forces. Yes, and horizontal forces. Okay, horizontal forces anyways this is going in the in this direction. Okay, it will merely stop, it will act as a friction. Okay, but this direction, this will disturb the plane. That's the reason whenever you are taking the plane, okay, the plane after reaching to a time it will move like this, it will move like this, and this movement is called as turbulence. This movement is called as turbulence. So my point here is, in the commercial planes, we'll feel both the horizontal and vertical winds. So here turbulence will be there. Here we'll feel only horizontal winds. So maximum it will act as a friction. So here turbulence will not be there. This is your UPSC question. Okay. So in commercial questions, like in commercial planes, we'll feel turbulence, and in jet planes we won't feel turbulence. Yes, the statement is true, because in commercial planes we have both horizontal and vertical winds. Here only horizontal winds. Okay, so here turbulence will be there. Okay, so turbulence is this only, but to explain this turbulence in physics, they'll take more time. But turbulence means this disturbance which you are feeling in the plane is nothing but turbulence. Okay, so whenever in future, if you are taking the plane, immediately, I mean, after reaching to a height, you'll for sure you'll feel turbulence. Then remember this concept. You are in commercial plane. There are vertical winds as well as horizontal winds. That's the reason you are feeling turbulence. Okay, and here turbulence will not be there. Turbulence will not be there. Done? Yes, this point understood, right? Turbulence. Any doubts still? Sure? Okay, fine. Okay. Now see. UPSC, one more question. See, generally in the rocket, what we are using, we are filling fuel. Along with the fuel, we are filling oxidizer. Okay. This is happening with rocket. And here the commercial planes, they will travel in troposphere. In the troposphere, obviously, we'll have oxygen. So, is there any need of oxidizer? No. So, no need of oxidizer. No need of oxidizer. Okay. Oxygen O2 from atmosphere will be used. O2 from atmosphere will be used. So, this is in troposphere. Okay. When it comes to stratosphere, what happens? Oxygen? No oxygen. Who told you? See, ozone layer is in which layer? Stratosphere. Why it is there in stratosphere? What happens is, when sunlight comes, if the sunlight wavelength is less than, if the sunlight wavelength is less than 240 nanometers, at that point of time, what happens is oxygen, this is stratosphere, and this is troposphere. Okay, so the oxygen which is there in the stratosphere, not every time it will come. Okay, in few incidences the wavelength will be 240, less than 240 nanometers. At that point of time, what happens is, if it is less than 240 only, this oxygen will be divided into nascent oxygens, but here not all the oxygens will be divided. Some oxygens will be remain as oxygen only. So these oxygens will be react with nascent oxygen, and they will form O3, ozone, which is there in stratosphere. So in the stratosphere also we have oxygen. Okay, that's the reason we have ozone. Okay, so now it won't reach this troposphere. This like this nanometers wavelength sunlight, this will be absorbed by these oxygen particles only. That's the reason they won't reach to this troposphere, and that's the reason in the troposphere we don't have ozone layer. Okay, so the layer which is above, okay, that is absorbing all this sunlight. Okay, that's the reason here itself the oxygens are divided into nascent oxygens, and these nascent oxygens are forming ozone. Okay, if this wavelength sunlight, if it is reaching, troposphere, then there are high chances in troposphere also, there are high chances we can see this ozone. Okay, generally again this people will discuss in this environment and ecology. But my point here is in troposphere also, in the stratosphere also we have oxygen. So here also no need of oxidizer. Okay, so O2 from atmosphere will be used. Atmosphere will be used. So your previous year question is in the jet engine, because it is traveling in the stratosphere, we will use oxidizer. We'll use oxidizer. Now the statement is wrong. Generally, we will not use oxidizer because in troposphere also will have oxygen. Okay, so these are two previous year questions. One is this one, turbulence. Okay, in the normal planes, in the commercial planes, you'll feel turbulence, but in the jet planes, you won't feel turbulence. Okay, and this oxidizer, okay, we don't need oxidizer either for commercial planes or for jet planes, but we need for launch vehicles. Okay, done. Understood all the points? Okay, now keep heading as types of jet planes. Types of jet planes. Types of jet planes. See, first I'll tell you, but no need of these diagrams and all. Okay. See, this jet planes, they will be working on three principles. How many? Three principles. Okay. First one is compression. Okay. And then combustion, and then expansion. Compression, combustion, expansion. Okay. Now see what are these things. Generally, a jet plane will be in this shape. A jet plane engine will be this shape. Okay, now whenever it is traveling in the stratosphere, what happens here is it will suck the air in the atmosphere. It will suck the air in the atmosphere. Okay, now while sucking the air, what it is doing, it is compressing the air. It is compressing the air. Okay, now this compressed air along with the fuel here, they'll burn here. They will burn here. Okay, once after burning, obviously here already this is in compressed form. This is already in compressed form. Okay, now we are burning on top of it with the temperature. Again the pressure is again more. Okay, once this pressure is released from this point, okay, so this will travel at a speed of subsonic. At a speed of subsonic. So initially we are taking the air, and here we are, what we are doing? We are doing compression. Here we are doing compression. Okay. Now compression, this compressed air along with the fuel will burn here. Okay. Once after burning, here the pressure will be increasing more. All of a sudden will release this pressure outside. So here what's happening here? Expansion. Expansion. Now this pressure will leave the engine at a subsonic speed. At a subsonic speed. Now Newton third law, for every action there will be equal and opposite reaction. Now this jet plane will travel in subsonic speed, which means less than 1 Mach. Less than 1 Mach. Understood? So in jet plane, we have three processes. One is compression. So while traveling in the atmosphere, it will suck the air. To suck the air, here there will be an instrument. Okay, this will be continuously rotating. In jet planes, that's the reason you will see two fans will be there. They will be constantly rotating. What they'll do? They'll suck the air inside. Once they are sucking the air inside, they'll do the combustion along with the fuel. Okay, now the air which was already sucked, first it was compressed. Already pressure is more. Now we are doing combustion on the other side, which means temperature we are increasing. Once we are increasing the temperature, the pressure will be further increases. Now all of a sudden we are allowing the air and the combust mixture to expand. Whenever it is expanding, it will expand at a greater speed, which is at subsonic speed. Now Newton third law, for every action there will be equal and opposite reaction. So obviously it will move in that direction in a subsonic speed. Okay, imagine this like this. See, you have taken a balloon. Okay, you have filled the balloon, which means now you have compressed this balloon. Okay, now you have heated the balloon. Okay, now all of a sudden, if you are leaving the balloon, okay, the air will come this side and the balloon will travel like that. Okay, the we are taking the air, we are compressing the air, and we are mixing that with the fuel, and then we are allowing that to combustion heat. Okay, now once after it is burned, now we are allowing it to expand. Now it is expanding at a speed of subsonic, and obviously the jet will travel at a speed of subsonic. Yes, clear? Okay, right now first type, subsonic. subsonic Subsonic. Okay, so this, sorry, sub. Okay, okay, fine, fine. Get back here. Okay, enough. See, first type is turbojet. Okay, turbojet less than 1 Mach. Okay, and this is subsonic. Generally, it will travel at a altitude of 20 to 25 kilometers. Okay, now second type, ramjet. Ramjet. Ramjet is supersonic. Supersonic. It will travel at a speed of 3 to 6 Mach. 3 to 6 Mach. 3 to 6 Mach. Okay. And third one is, here it will travel at a distance of 30 to 35 kilometers. 30 to 35 kilometers. Okay. And third one is scramjet. Scramjet. This is hypersonic. This is hypersonic. And this will travel at a distance of 40 to 45 kilometers. 40 to 55 kilometers. Okay, so 40 to 55 kilometers. This can take a speed of 24 Mach. This can take a speed of 24 Mach. Okay. Now see application part. Listen. This generally will be using in fighter jets. Okay, Rafale, Tejas. Okay, in those fighter jets, we'll use a engine which is turbojet. Okay, and in some missiles we are using rocket, and in some missiles we are using this ramjet as well because the speed is more. Okay, so if we want to develop a hypersonic missile, then what kind of technology we are required? Scramjet. So the countries which are having technology of turbojet, they are making fighter jets, Tejas, Rafale. Okay, these all things F-15. Okay, and the countries which are having technology of ramjet, they can do missiles. They can manufacture missiles of supersonic. Okay, okay. Generally, our BrahMos 1 is supersonic missile. Now we are looking for hypersonic missile. So there we need a technology called scramjet. Okay, simple. So if we have this technology, fighter jets or subsonic missiles, both we can do. Okay, if we have this technology, supersonic missiles we can manufacture. If we have this technology, obviously we can manufacture hypersonic missiles. Okay, so this is the application part. Right on. This is just jet engine technology. Understood, right? So first we have compared jet engine with commercial engine. Okay. So and I have told you commercial engine will feel the turbulence and jet engine will not feel turbulence. Okay. And oxidizer is not required. And jet engine are of three types. One is turbojet, ramjet, scramjet. Turbojet is subsonic, ramjet is supersonic, and the scramjet is hypersonic. Okay. Turbojet, fighter jets and missiles of subsonic type, and ramjet missiles of supersonic types, and scramjet is missiles of hypersonic type. Okay, so write down their application part. Okay, now take a short break and then we'll continue with this Chandrayaan 1. Fine. Chalo then take a short break. I mean 10 minutes only or 15 minutes, not more than that.